All right, so guys, I'm going to solve this quickly because we only have 5 minutes left. So here's a diagram of the problem. We have, I'm just going to draw a soccer ball. So what is it, a quarterback throws a football? That's too much artwork. I'm just going to go boom. We got a ball that's being launched at a 30-degree angle. Okay, so this V initial here is 20 meters per second. This angle here is 30 degrees. And what they tell us is we have a guy who wants to catch this ball who's standing 20 meters away. Okay? Now, does that mean the ball is going to land 20 meters away? No. In fact, what they want us to figure out, they want us to figure out which way does this guy need to run to catch the ball. You know, does he need to run to the left, towards where the ball was thrown from, or does he need to run to the right, away from where the ball was thrown from? So basically, let's forget about the dude for a minute. Let's just kind of forget about this guy, forget about the 20 meters, and let's just figure out where the ball is going to land, then we can answer the question. All right, so to do this, you know, the ball is going to go up like this, it's going to land over here. So let's figure out where will this ball land, right? So to do this, can we just solve for x directly? Nope. What do we have to find first? Time. We got to find time in the air. Now, whenever you're solving for something, you know, with a motion equation, you got to decide x direction or y direction. So we got to break this 20 meters per second apart. That's got to get broken apart. So here's what it breaks apart to. The x component of this velocity of the 20 is 17.32. The y component of that initial velocity is 10. And what else do we know? We always know acceleration. Acceleration x is 0. Acceleration y is gravity. Okay. The way I would solve for time, what I like to do is solve for the time to the maximum height, right? If you can find the time to there, then what do you do to get the total time? Then just double it. So I'm gonna find the time to the maximum height. Now, what's nice about the maximum height? At the maximum height, we know the y velocity. Vy is 0. So now what we can do is we can go like this. So using the y direction, we're going to go Vy final equals Vy initial plus gt. That's the third kinematic. Vy final is 0. So now you can solve for t. Negative Vy initial over g. So that's negative. Vy initial was 10. And then g is negative 9.8. So the negatives cancel. So the time to the maximum height is 1.02 seconds. So what's going to be the total time to get over to here? 2.04. You just double the time up. So we now know that the total time the ball spends in the air is 2.04 seconds. Now we can get this x. How can we get this x right here? Well, what's the only x equation? Vxt. Our x velocity is 17.32. Time in the air is 2.04, like that. And then we get 35.3. What is that? I can't read my writing. Who got this? Is it 35.3? 35.3 meters. Okay, now we can answer the question about which way the dude needs to run. Okay, so let's make some space. So where is this guy standing? They tell us that the guy is standing where? 20 meters, so he's in here somewhere. Here, let me clean this up. The guy in this problem is standing, the guy in the problem is standing in here, right? Somewhere in here, like this. So which way does the guy need to run? He's got to run to the right. Now, how far does the dude need to run to catch the ball? 15.3 meters, right? Because that's the difference, right? He's got to go 15.3 meters. And how much time does he have to do it? 2.04. So his velocity, you know, you're going to go displacement over time. In order to catch the ball, he's got to go 15.3 meters in 2.04 seconds. So he better run at about 7.4 meters per second to the right. How's that for timing? Hey, Engel, anything you say is being recorded right now, so watch it. Okay. Parents are going to hear this. I'm joking.